So some elementary calculus that we can do with a vector function would be to take the limit of a vector function. So we're going to assume once more that we have a vector-valued function in R3 with component functions f of t, g of t, and h of t. So with that in mind, if I want to take the limit as t approaches a of r of t, then that would be take the limit as t approaches a for all three of these cases. So limit as t approaches a for f of t, that'll be the first component. Second component will be the limit as t approaches a of g of t. And finally the limit as t approaches a of h of t for the third component. And this of course assuming these limits exist. Now with that in mind, let's consider one such vector function. Let's say that r of t is equal to, let's do the function sine of pi t divided by t squared minus 4. Let's do t squared minus 2t over t cubed minus 8. And finally, let's do the square root of t plus 2. What I'd like to do is find the limit as t approaches 2 of r of t. So rather than trying to do all three of these at the same time, I think what I'd like to do is break it down and do each component separately. So first we'll consider the limit as t approaches 2 of the sine of pi t divided by t squared minus 4. Now if you were to attempt to use the direct substitution property, which would be just go ahead and plug in t equals 2, I'd have the sine of 2 pi over 2 squared minus 4, which is 0 divided by 0. That is an indeterminate form. As such, I am going to apply L'Hopital's rule. Now if there's something else that you can use from back in Calc 1 to help you out with this, of course I encourage that behavior. Derivative of the sine is the cosine, and chain rule says we should also multiply by an extra factor of pi. Derivative of the denominator is simply 2t. If we attempt to use the direct substitution property one more time, it works out much more favorably this time. So that'll be the cosine of 2 pi, which is 1, times pi, divided by 2 times 2. So our first component is going to wind up being pi over 4. Now as far as the second component is concerned, we do have a polynomial divided by a polynomial. And again, if we attempt to use the direct substitution property, we're going to wind up with 2 squared minus 2 times 2 over 2 cubed minus 8. That is once again 0 divided by 0. If you would like to use L'Hopital's rule, you are welcome to do so. What I'm going to do is factor the top and the bottom. Now I know automatically that because I plugged in t equals 2 and I got a result of 0 in both the top and the bottom, I should be able to factor out a t minus 2 from both the top as well as the bottom. The numerator, all we need is greatest common factor, and in the denominator we need our difference of cubes formula. From here you are allowed to cancel out the t minus 2's and then apply the direct substitution property to what you get after that. That is 2 over 4 plus 4 plus 4, which will reduce down to 1/6. And finally, for our third component, don't say I never did anything nice for you. We plug in t equals 2, we get 2 plus 2 under the radical, which is the square root of 4. Square root of 4 would be equal to 2. Therefore, the limit as t approaches 2 of r of t is going to be the following vector. The components will be, in order, pi over 4, 1/6, and 2. Now I did check the math on this one. What we did is we turned one Calc 3 problem into 3 Calc 1 problems. I like it. The math even checks out on that.